Hello everyone, and welcome to the snake game. Today we're going to be creating a snake-like game that will have a score counter on each side, food that shows up. As you can see, I've added in the food a lot faster so we can get a you win screen eventually, but we'll be playing with two different players, and the snake will grow but also disappear behind you. I'll show you how to do that faster and slower, as well as the you win screen at the end. So hope you guys are excited. I hope you guys enjoy the video. Let's go ahead and get started.
So at this point, I'm going to create a new scenario, a new Java scenario, and we're going to create our snake game. The first thing we're going to do is want to go to my world snake game, and so we want to be able to access our background, and then we want to change the color of the background. So we want to be able to get the background. So this is a method, and then you're going to set the color of that background that you just got. So this set color will has a parameter that requires a color. So you do color dot black. And so we are able to build our my world just by getting the background and setting the color. It knows we're talking about the my world background. Okay, and then you can do get background dot fill, and that will fill the background. So we've set the color of the background to black here, and then we've done our fill method right here. Okay, and now when we compile, now we have our black background. Okay, entirely black. So we know we're going to have players that are in this game, and we're creating a snake game. So we'll have two players. One will be green, one will be blue, and they'll move around the screen. If they collect a certain amount of apples, they're going to win the game. They cannot run into their own tail or their partner's tail, or the other player's tail, or they will lose. So we know we need to make a players class, and we know we're going to be able to make a foods class. Player. And our player is not going to have an image because we are going to design our own image here. Okay, and so when we open our player, we know we're going to need a constructor because we're going to need to be able to build the player, the look of the player. And we know we're going to need to have a color as well as their own controls. And within this constructor, we know that our players are going to be two different colors. So I'm going to give them a red, a green, and a blue set of parameters. Okay, and so I know that 0, 0, 255 will be blue, red will be 255, 0, 0, green, 0, 255, 0. So I can create my different colors there. And then when I add a player into the world, we could do it in the constructor. We know that we're going to need to add the object into the constructor because before the game even starts, we want them in the constructor, but we don't want it local to just the constructor of the world. So we don't want to add it in there. So once again, like we made a counter in our Flappy Bird game, we are going to make a class for players. Player, blue player equals new player. And they will be 0, 0, 255, because that's our blue player. And then player green player equals new player 0, 255, 0. Okay, and for now, and if you wanted a red player, it'd be 255, 0, 0, and you could mix and match to make different colors with that if you wanted other colored players in our game. Okay, so what we're going to need to do with that is now that we've made those two objects, we can add them in. And so add object. See, if I don't want to go look, blue player, comma, their X and Y value. Let's go ahead and make it 450, 100, and then add object green player at 150, 100. So let's change this 100 to 300. Now we will have two objects in the world, and we'll start them both going up. But now what do we do once we add these in? How do we communicate that these are getting passed to the player? Because they are. Okay, we've done it here. We've made a blue player and a green player. So how do we get this information? So they have been passed, but how do you receive them as the player? Well, you need to create different variables that will match the variables in here that can be accessible in the player class. These can be received and read in the player class, but they cannot be stored unless you do it. Okay, so we can actually, if we're creating multiple integers, we can just have them next to each other, especially if they are very related to each other. So we have all the colors RGB, and you can do this R, so the R that is this instance of R, whatever it is. Okay, so whichever one in the game it is, this instance of R will be whatever R got passed to it. And so in our game, both of the players had 0 red get passed to it, but our R equals R. Okay, and then this dot G equals G. Which the green had 255 passed to it, but the blue object, the blue player, did not have anything passed to it. Okay, and then this B equals B. Okay, so now that we have this, whatever instance we're talking about, we have their R, G, and B, we need a set image, we need a get image similar to the background image. We need to access the current image of the player, and we are going to set their color just like the background. We're going to do a new color, and we're going to put R, G, and B in there, and that way, whichever player we're adding into the world, whether it's the blue or the green, they're going to have their own color, and then we're going to get image dot fill a rectangle image 0, 0, 40, 40. Starts at 0, 0 of where we're adding the object in, and then it grows to 40, 40. Now we have our green and blue player in, but we want them to move a little bit. So first I'm going to set their rotation. So they're facing up, 270 rotation. I'm going to do that for both of them. And I've already done it for both of them. Okay, so they start facing up. And now I want them to move, and we'll go ahead and put speed in there, and we'll create a variable for speed. And speed equals 3. Don't want to move too crazy fast. Now that we have speed in, we can go test real quick, and it shows both of them are moving up at the correct speed. And then we are going to need to create if statements. Greenfoot dot is key down. Right. We can set the rotation to 90 to 0. Okay, and we can indent that correctly. If Greenfoot dot is key down left, $180. copy, paste, paste, and let's change these. Up back to 270 and down to 90. Okay, so now we can move along the screen with both players. We're going to have to change that up a little bit later if we want to have one controlling the other. But let's go ahead and make the tail. Okay, and so our tail needs to be another actor. So our tail, we're going to go in and we are going to public tail and we are going to need to create a way for the tail to access the RGB of the player and make sure that it is the same color. So when we create our tail, we need to make sure our tail is able to get the colors, receive the colors of the player. So we need to have its own R, G, and B, and R, G, B. Same as before. This dot R equals R. This dot G equals G. This dot B equals B. Okay, and the way they are going to receive this is when we go into our player, we're going to add in the player's RGB and pass it to the tail so that the tail has the same characteristics as whatever player we're talking about. Okay, and so now the tail receives this RGB, but it needs to do something with it. So we need to get image dot set color, just like before, new color, R, and we know what's referencing the R of the tail, but it's setting that when it gets the R of the player, GB, and then get image dot fill rectangle 0, 0, 40, 40. So now when we run it, they will have the tail follow along, and we've made a nice little game here. Okay, now we need to make sure, first of all, that the tail doesn't go on forever, but we have the colors of the tail because we got them passed to us from the player's RGB. Okay, so this is referencing it from the player, and it's plugging it in to the tail, and it's the tail storing it with these, but it's receiving it through this. Okay, and so with our tail in the act method, we want to have another count for our tail, and we want this tail to disappear so it looks like it's following along, because before we just run it and it just is a cool looking tail, but if we have it disappear from behind, we actually have a ton of, if we pull out, see, these are all a bunch of little objects, and we're first of all going to run out of space probably at some point, and it'll be working Greenfoot too hard and it might crash. So we want to delete following behind, and we'll have a count equals 0 to start, and then if count, we'll have count plus plus, so it just adds up the whole time. And if our count is greater than 60, so every second, it'll last for 1 second to start, you're going to, for now, just get world dot remove object this. So that's referencing this instance. So each one will have its own counter. So after 1 second, it'll follow along, and now you have a nice little tail to start your game. Okay, so now we're going to create another layer of the player so that it can have more than just the 4 directions, and each player can have a different direction. So int player, so our players are going to either be a 0 or a 4. And so in our my world, we need to add another one that's the blue player can be 0 and the green player can be a 4. And so what this allows us to do is now we have one player that's a 0, one player that's a 4, and we can access that player int, and we can add that on right here to make another player integer. You need to make sure you create that variable, and since these are all together, I can put commas next to them. I'd prefer to put these alone when there's something different, but these are all our parameters. So the player, so here we're going to have to do a nested if statement. So if player, that's the variable of this player, we'll do this dot, although we don't need to, but just to reiterate it, if this dot player equals 0, and right, left, up, or down is pushed. So if we do Command Shift I, you can see how this adjusts. All these get moved out in the correct spot. And then I'm going to copy that, paste it, and if this dot player equals 4, they're going to have different commands. They can have right D A W S. You need to make sure you set your player to this dot player equals player, and then this dot and this dot. Now you have different snakes able to do all sorts of different things. Okay, now we need to have some sort of damage done, but before that, let's go ahead and create our counters. And so we're going to have our counter class, counter blue counter equals new counter, counter green counter equals new counter. And we're going to add object blue counter at 450 50 green counter at 150 50. Okay, so now just need to do what the green and blue counters look like. And actually I'm going to change 450 to 550 and 50, 150 to 50. Okay, and then I'm going to have the counters. You need to create the physical properties, characteristics of the counter. So you need to create a constructor to construct your counter. So with our counter, we're going to set the image to a new Greenfoot image. And the new Greenfoot image is going to be a string then font size, and then foreground, and then background. So color dot black, color dot white. So these, once they have text in there, would be the location of our string. So if we want to put a little bit of text like our score, then we can put that in there. And that might be a little bit big. So we can change that to about 30. I think that'll be just about right. Okay, here we go, score. Okay, and then once we have that, we need to have int speed, int score equals 0 to start. And we want to make sure that's public because we're going to be accessing that in different places. And then we want this to be not only in our constructor, but also in our act method, because our act method is going to update our score. And so we need this is a string, and that's what's required here. But we need to make our variable that's an integer turn into a string. So when you add this plus, or sometimes later on you'll do parentheses, is called concatenating, and it just makes the value, makes sure that this is a string. So whatever's in front, or concatenating a string, you would have to do a plus. With numbers, you would do int or double or boolean, but for our string right here, we want a plus score and plus score, and this will live, once we add the score method, it'll live update the score as we go. Okay, and so our score is 0, and it can go up as we go once we create that method. So let's go back into our counter class and create that method. So public void add score. And we are not going to have a parameter passing to it because we're just going to add score up by 1, just to have a regular count. When we go back, our score needs to add score when we eat food. So we're going to create our food. And our food is going to have the same code as our player. Actually, it's going to have the same code as our tail. So here we can copy and paste, but we're going to be food. And we can have a count as well, because I want our food to disappear if our count is greater than 400. Get world dot remove object this. Okay. And then we're going to go to our world and we're going to add food in randomly all across the screen. So we need to do a public void, finally create an act method for our world, and we are going to count plus plus our world, and we can just do int count equals 0. So if our count is greater than 100, we will add object new food, and they will be red to look like apples, and they will be located Greenfoot dot get random number get width -1, copy, comma, get height -1. I believe the parentheses are correct. Nope. Okay, so we create a new food that's red, and we have the X value be located Greenfoot.getRandomNumber with -1 close parenthesis here. That's what we'll take out the parenthesis back here. Okay, because this is going to be the random number that we're going to get, and it's the height of our world. So anywhere between 0 and the height of our world, then it's going to be completely random, and this is going to be anywhere from 0 to the width of our world. Which I don't think you need to do -1, but I'm going to do it just in case. I think it goes 0 to just before the edge of the world. So there goes our apples, and they're getting added in, nearly immediately. So we need to change something, because count is consistently greater than 100. So we're going to need to change count back to 0. And this has to be inside the if statement. And then Command-Shift-I. There we go. And now, there it is. Okay, and then we can add another one. And they disappear. Okay, and we have about 4 up at a time, so that's pretty good, I think. I'm going to make the size of our world a little bit larger. So I'm going to go ahead and do 7 by 5. And we might need to add 500 to this. And the location of the blue counter could be 650. And the height of the world could go up by 100. Players. Yeah, here we go. And now we want to actually add the score when we eat the food. So let's create a method for move around first. Public void move around. Let's go ahead and move that in here. Just have move around, and then say eat food. So we're going to create an eat food method. So public void eat food if is touching food.class. So we need to be able to access the counter from my world, which we do, but we need to be able to access which counter. And so we need to go back into our player and say if is touching food.class and player equals 0. Well, we know player 0 is the blue player. So we need a way for our player to be able to access our my world class, and then within that my world class, they want to be able to access the blue counter that we have stored for our my world class. Okay, and so if we go back into our player, they have the ability to access the my world class, by doing my world, my lowercase my world. So we're creating another reference to our my world now, and this is a little bit different. We need to concatenate. So remember when we turn like a string we had earlier in the counter, we turn this string, or excuse me, this integer and morph it with the string. Now we're going to concatenate my get world method, which grabs a world, and we are going to make it of the type my world. So we concatenated it to making it a my world class, and then we're going to call it lowercase my world, so that when I do my world dot, I am referencing specifically the my world, the get world of my world. So like the current world that we're in, we're accessing the current world. We're gonna make it of the my world class type, which makes sense that that would fit because we're getting the current world, which is my world. We're creating a reference for it. Okay, so we can go into my world. We can access blue counter because that is a method in my world, and then within that references to the counter class, which has our add score method for our blue counter. So dot would be another reference, and then we can add score method. Now watch, this works and it compiles. So when we're going, if you look at our score, we actually need to move this and have it only local because it gets confused. It needs to be local only where it's used. So only in this blue counter dot add score. So now you can see, if I move my score out a little bit, my score for the blue counter going up, and the score for the green doesn't do anything yet. So we have our own separate counters. So in our player, we're going to copy this and paste it. But if player is 4, we're going to go to the green counter and add that score in. So there's our green counter going up, and then our blue counter going up. And now we need to make sure that food disappears. So else if our food is touching player.class, get world dot remove object this. If our count length is greater than 10, we'll do 15 to start, and is touching player.class, you are going to get world dot add object new you lose get world dot get width divided by 2, get world dot get height divided by 2. And we need to make a you lose screen. We can do a game over screen for our you lose. Make sure you have these in the correct order. You can't have anything after the remove object this, or else it'll come up with an error. But there we go. If we run into ourselves, game over. If we run into the other player, it's a game over as well. So we just need to have player, or excuse me, tail. We need to add the object, and then we're going to have a simple Greenfoot.stop if we lose. Okay, and then in our counter, add a public void you win if score equals 10. Get world dot add object new win get world dot get width divided by 2, get world, oh this beautiful, get world dot get height divided by 2, this beautiful code that you have to do over and over and over again. Gotta love it. Then you can do Greenfoot.stop as well, and we can just end our game there. We don't need to go wasting any time on stuff we've done before. So we need the uWin screen, and we also need uWin to be put in the act method. Win. We need a new actor called win. No, not the best uWin screen, but that's what we're going to work with. Okay, so see who can get to 10 first. We won. Okay, so if we have 2 players, hopefully 10 would be enough. If you want to slow down the speed at which you're going, that's way too much. But hopefully your control will be a little bit better if you have 2 people. All right, there you go. So that is our snake game. Now we will go and move on to the final game, which is our piano project.